Hello! This video will go over the tips and techniques for fusing scans and post-processing the resulting mesh. Selecting Editor from the left ribbon menu shows a list of the editing tools available. Use rough positioning to drag the scans or model around with a gnomon. Precise positioning will be used in the next video in conjunction with the Construct menu. To erase unwanted features, such as the base from this scan, select the Eraser tool. The Eraser has many selection tools, but 2D selection will suffice for now. The Select Through checkbox specifies whether or not unseen points will be selected. To select points, hold down the Control key and left mouse button. This will show the brush and allows for selection. Using the scroll wheel and Control key, you can change the size of the brush. After selecting points, delete them using the button in the menu or with the Delete key. There are also options for hiding the points, deselecting everything, or selecting the inverse. Once all of the unwanted points have been removed, navigate away from the editor menu. The deleted points should be deleted from the model now. If more than one scan has been taken, the next steps will need to be followed to align these scans. After selecting Align from the left ribbon menu, the various options for alignment are shown. The default mode is Best Fit. This is what we will be using. The last video in this series will touch on textures and when you may want to use the texture alignment. Leaving all the default settings, select Auto Alignment. This will automatically find datums in each model and will align them all. If the alignment is correct, make sure to click the Apply button before leaving the Align menu, or the changes will be lost. The first step in creating the fused model is to complete scan registration. Both rough and global registration need to be done. These register and optimize the individual frames from the scans. Optionally, the fine registration can be completed as well. This more thoroughly adjusts the frame positions relative to each other, treating each batch of scans separately. Artec Studio features 3 different fusion modes. As the name suggests, fast fusion is the fastest, although the fused mesh suffers from large amounts of noise. Although the final model can be less visually appealing, this fusion mode is very efficient when measurements are needed quickly or when the model contains an extremely large amount of data points. Fast fusion doesn't have support for filling holes, but both smooth and sharp fusion have this capability. Smooth fusion is best used for scans that contain large amounts of noise, such as a shiny or moving object. This mode will sacrifice some accuracy, but in turn allows for a mesh that contains less irregularities. There are options for filling all holes in the model, filling smaller than a specified radius, and to fill no holes. Here is an example of the fusion being created with no hole filling. And here is the same scan, but with hole filling enabled. Notice that this time the option to exclude erroneous frames is also enabled, with an error level specified. This will drop all the frames above a certain error level and is extremely useful for scans that contain a large number of frames. Sharp fusion will take longer, but the resulting mesh will have more detail and less noise. When scanning with the Eva, the 3D resolutions should be no less than 0.5 millimeters. Leaving this as the default value is usually a good choice for the type of objects the Eva can scan. If the intention is to print or otherwise use the resulting mesh in any computer-aided manufacturing software, the watertight setting in the Fill Holes drop-down menu should be selected. Viewing the resulting mesh, the difference in noise between the sharp and fast fusion is immediately noticeable. Applying the small object filter will allow you to filter and remove some of the resulting meshes. Selecting All Except Largest allows for the deletion of every mesh except for the mesh containing the most polygons. There is also an option to delete all meshes with the polygon amount lower than the specified amount. Using the All Except Largest option will leave us with just one mesh when we export the model. Activating the wireframe view mode, we can see the large amount of unneeded polygons in this mesh. After selecting the mesh in the Objects window, the total number of polygons is shown below in the Features window. Currently, this mesh has over 800,000 polygons, which in turn will require much more RAM when loading after exporting. Mesh models with too many polygons won't load in most CAD softwares and will be very laggy in animation and rendering softwares. Mesh simplification will decimate the mesh until the number of polygons is below a specified level. The amount of polygons needed will vary based on the detail of the model, so it's a good idea to make a copy of the fused mesh to experiment with the polygon count. Using a value of 10,000 resulted in a loss of too much detail, where a value of 20,000 worked well for this model. While it's difficult to define exactly how many polygons is enough or too much, selecting a value between 5,000 and 30,000 can be a good starting point. Switching to Auto mode by clicking Auto at the top of the Tools menu will allow for easy and automatic fusion and post-processing of the model. The only thing required is selecting the type of registration, type of fusion, and any post-processing algorithms. The smoothing option will iterate over the polygons and apply averaging algorithms to the vertices in order to flatten out the mesh wherever possible. Recalling what was previously stated about the noise levels in fast fusion models, this fused mesh is no different. Zooming in, you can see all kinds of islands and noise. Although smoothing was applied, this didn't help much. In order to export a fused mesh, first make sure the desired mesh is the only one selected in the Objects menu on the right. After selecting the mesh, go to File, select Mesh, then click Meshes. The file location, name, and type can now be entered and the mesh saved. That will be all for this video. Make sure to check out the next one where the model will be prepared for use with SOLIDWORKS. Thanks!